All right, next up, in this polynomial, how do we graph it? Well, short answer is we use our calculator of some sort. Longer answer is, what if we don't have a calculator? What can we look at? Well, we can always pick x values, any x values. I could even pick values like -1,000,000, but that's not typical because then I'm going to have to graph -1,000,000 and no thanks. But whatever it is, I plug that number in. So everywhere there's an x, I'm going to put a -3. And then after I do that, I'm going to put it in the calculator, or I'm going to use my brain power. And my output here is -11.5. For time's sake, I'm going to be your human calculator, but feel free to hit pause and fill this table out yourself. All right, here we go. So notice from -11.5 to 6, the number is increasing. And then from 4.5 to 2, from 6 to 4.5 to 2, it's decreasing. So I did that arrow upside down. It was increasing here, decreasing there because the numbers are getting smaller. From 2 to 4.5, the numbers are getting bigger again. 6 as well. But then 6 to -11.5 is decreasing. So what this can help me do is kind of figure out the flow of my graph when I'm ready to graph it. Okay, these are called turning points, and we can approximate them right now. Okay, we do not, so in quadratics you had -b over 2a to figure out those turning points. We do not have a cool formula to find those other turning points. It does involve calculus, and you're not there yet, so I would not ask you to find the exact turning points unless you're using a calculator for now. All right, so if I graph these, so that's way down here, -2, 6 is here, 2, 6 is here, 0, 2 is here. So we have something to look like this. Remember, whoops, that's a little off, but that's okay. We don't have hard turns, okay? Bottom points like this are what we call relative minimums. We've talked about this before. Remember, in this particular case, we only have relative minimum because the absolute minimum would actually be -infinity because it keeps going down forever. Okay? I'm sorry if you hear my dog. So this occurs as 0, 2. And then if we have relative mins, we can also have relative maximums. We actually have 2 maximums here. We got 1 there and 1 there. Even if it's like this, even though that one's higher and this one's lower, they're both maximums, relative maximums. This one would just be absolute because it's the highest. All right, and these occur at -2, 6 and 2, 6. And in part B here, I'm going to go ahead and do this in this video. Remember that average rate of change is slope. And this is an interval, so these are x values, okay? If I'm trying to find slope, I have to know the y values. So -2, 6, and then 0. I'm doing it here, okay? So -2, 6, 0, 2. Sorry if that made you dizzy. I won't do that again. So now I have the x values and the y values. So when I do slope formula, y2 minus y1 over x2 minus x1. If I want to write it the algebra 2 way, which is the fancy way, it would look like this. But if I'm being honest with you, I'm not going to write it that way. It's just slope formula. So 6 minus 2 over negative 2 minus 0 is 4 over negative 2. So the average rate of change is negative 2.